Our next speaker is Tomas Czechvala,
Right.
who is going to be talking about FastDataStacks, which is an OPNFV project related to the integration of VPP and other FDIO projects into a stack. Okay. So.
Right.
Do you still need to do your presentation?
Sorry? Okay. So, hi everyone. My name is Thomas. I work on FDS. I contribute to this project, which is based on software-defined networking, or let's say virtual network function. So, yeah. So what do we do? OPNFV, FastDataStack, is a platform that allows you to use a very complex solution where you can just define your business logic that you have or that you want to implement in your network. Given the fact that you don't have to really care about how the devices are configured, all you need to be aware or all you need to define is some kind of topology or policy or some kind of rules, who can speak with who and how, and you don't need to care how that is done in the underlying network. So OPNFV is a pretty complex suite. It's designed in a way that you can just install it, and you don't really need to go through all the complicated installing of multiple components that is used there. And once you have it, then you can just use it out of the box, let's say. So in this picture, there's a very brief description of how when we decompose our problem, then we are operating mostly on the network controller layer, where our forwarders, routers, and switches, and we're trying to manage them and configure them by some kind of automation that we implement in components above. Then there's a virtual machine layer when we actually spin up a VMs in our suite. So you just need to tell, I want a VM on that node, and then all these suites should give you the node, and you can use it right away. And there are also services one layer above that takes care, let's say, about managing your nodes and running some services that are related to it. So let's say a metadata service that can inject some configuration to your node and other services. Okay, so there's Open Daylight. It's been discussed before. So we use that for configuring various underlying network types. We currently work on VPP. We also done some work on OVS, and also physical devices can be also incorporated in our suite. So when speaking about GBP, GBP is a plugin in Open Daylight, and it's a plugin that allows you to transform a policy into a network configuration of devices. So you take your logic, your business logic, use cases, and GBP will transform it in a config. So let's move on. Okay, this is another view on our suite. So there are also layers, and as you can see on the bottom, there are forwarders, OVS DPDK, which are also in some suites available as a use case. And in our use case, we add VPP. So our scenario is mostly OpenStack for controlling VMs and for having an abstraction layer on the very top. Then there is Open Daylight, where we use a GBP for receiving those requests from OpenStack and transforming them to underlying network, and also hypervisors for hosting the VMs, right? There's in the middle, and then there are forwarders. So we're currently trying to involve VPP as an underlying technology. So there are also other scenarios that currently are in progress. The first one, which you see with Apex, OpenStack, OpenDaylight L2, KV, and VPP, that's already what's working in our scenario. Then there is L3, which is in progress. So we're kind of want to route traffic between the nodes without really touching the kernel space, but just keeping the routing in a user space by using DPDK. And there is also another scenario which is in progress, and that's that OpenStack directly talks to VPP. It's just that it exists. We don't really work on it now, but someone else is. And yeah, here are some more details about our suite. So OpenStack is on the top. Neutron plugin, which is there, it's a key component because it allows you to define network, subnets, ports, security groups, and all this abstraction that is pretty simple to define. Then there is a REST API. So Neutron sends a REST request into GPP. There is a project Neutron Northbound that has a modeled. This is also a model-driven plugin, and so that's where the data are stored. And underneath there's a GBP project which listens to this data model and reacts on the changes in config data store, transforms by using render manager, VPP render, all this policy into a configuration on FDIO. And yeah, FDIO is actually it's a collection of projects that includes DPDK, VPP, and also Honeycomb. Honeycomb is like a lightweight ODL that it's capable of netconf communication between ODL and Honeycomb. Yeah, so as you can see, we use netconf there, and because VPP doesn't have any API that could be directly used by ODL. Honeycomb actually transforms these netconf requests into and then uses a C API that is available on VPP. And so it's not that we directly configure VPP with ODL, but we also use Honeycomb for that. So given the fact Honeycomb has to be on every node together with VPP. And there is also a system installer, Apex, and there are also system tests that are involved in OPNFV. So Apex is actually the project it's a program that installs all of this for you automatically, and func tests ensure that everything's working as it should. So here's a detailed view on how, let's say, when a port is created, how it goes down to the VPP from very top of Neutron in OpenStack. So let's say we create a port with some binding details. Those data are written into Neutron Northbound in ODL. Then they are mapped to a GBP policy, because GBP is a standalone application. You can define any policy also in there. It doesn't need OpenStack. It can work on its own. So the matter of fact is that the abstraction that comes from OpenStack has to be transformed into one that is in the GBP plugin in OpenDaylight, and then we have pre-distributed rendering of configuration on different nodes, different type of nodes. So if there is a VPP node, then render manager will we'll create a configuration for VPP renderer, and VPP renderer, by using topology manager or directly sending requests to Honeycomb, can configure interfaces and bridge domains on VPP. The topology manager component is not a part of GBP. It's a standalone plugin, and it helps you create a full mesh topology based on where do you create bridge domains. So if you have bridge domains with the same ID on different nodes, then the VPD project will create and configure VXLAN tunnels between them in a full mesh. So you don't really need, it kind of helps you. And VPP renderer, it configures interfaces on a VPP itself. So this is how it's currently done. Okay, here's a workflow, let's say, of how OpenStack knows that some of the nodes, or one of the nodes is VPP. OpenStack doesn't have the knowledge about where is a VPP node or where is a OVS node unless we tell it directly, or unless ODL tells it. There are features for periodically scanning into ODL data store and looking for a configuration for a given node. So it's a job of ODL to write data for OpenStack into its data store correctly, so that OpenStack can read those data and save the proper configuration for a given node into its database. It's called Agent Database. It's a Neutron project. So whenever there is a config read by networking ODL, those data are parsed and they are saved in this agent database. And then later, when you want to create a Nova instance or deploy a VM on a given node, then you, before Nova actually creates it, it looks into this database, looks for the configuration for a given node. If it finds that configuration, it uses that config, and then we'll create a vhostuser interface right there on the corner. So, so Nova will create a vhostuser interface in a server mode, and on the other way, ODL will receive a notification that port should be created. Networking ODL is going to tell it, and then GBP will configure an interface on a VPP vhostuser interface, but in a client mode. So when the VPP detects the socket file on a VM and opens it, then the VM is successfully bound to VPP. Okay, so here we have a L2 scenario that we currently support. So as you can see, there are bridge domains on every node. We have same bridge domain ID on these three nodes. So VPD project configures VXLAN tunnels between them for us. And because it's L2 scenario, which means that ODL doesn't route packets, it only switches them or forwards them through the tunnels. Then we use QRouter, which is an OpenStack component for routing the traffic. So all we need to do here is to have some kind of centralized node where we create the tab interfaces, and they will connect to the QRouter, or let's say QRouter will text them into its namespace, and whenever there is traffic going from bridge domain to a different bridge domain, it has to go through the QRouter. The next scenario is L3 scenario, where we do the routing by using GBP, Open Daylight. So there's no need for having a queue router anymore. All we do is to configure routing on a VPP. So what does it mean? It means that you need to specify a VRF where you would like to forward the packets or route the packets. And into every bridge domain, you need to assign a BVI interface. So it's like an interconnection between a bridge domain and VRF. That's what BVI interface does. It's a L2 type of interface. And the third scenario I was talking about that lacks GBP or ODL entirely. It's shown here. So there has to be an agent on every node, which is actually managed by OpenStack, and OpenStack directly talks to VPP and configures it with CAPI. Okay, and now here's a simple cookbook for how to create a VM. So what you need to do is to get an image as shown there, and then by turning on huge pages and using a correct flavor, you can then create a VM out of that. There are also commands for creating a network, router, bridge, subnets, and ports. And then NovaBoot will spin up the VM, and VPP will ensure that, or GBP will ensure that it's going to be connected to the VPP. Okay, so here are some outputs of such a demo, but let me show you a brief video that we pre-recorded. Okay. Okay, let me stop it for a while. So this is a pretty complicated scenario that we're currently trying to work with. As you can see, there's a VXLAN tunnel, the green highlighted with the green color, and through which we would like to do some performance testing. So we are currently about to test some performance. But in this video, we're just doing switching between the green bridge domains on one, between those two nodes. So okay, it should be running. Okay, so here you can see interfaces on VPP. That's a command line output. So for VXLAN tunnels, we need the IP address so that they can reach each other. Okay, then we install or we start Karaf, and there's a grep command for seeing whether there was a connection between the nodes, the remote nodes, and the controller. Okay, so well, this is probably another node. IP address of another interface. So these two are going to be used as a VXLAN tunnels. Okay, and now we are starting to create some abstraction with OpenStack. There's some service listing. So services that Nova uses and services that Neutron uses. As you can see, we have an L2 agent enabled, but we're not gonna. We would use it if we would try to ping to the external networks, because there has to be some routing done. So we put a BVI interface in a bridge domain and then into external network, and then we could go outside. But in this video we stay inside. So as you can see, there's a metadata agent which injects some configuration into VMs, and also DHCP agent that runs the DHCP service on a control node so that VM can observe an IP address. Okay, there's a network that's been created. A subnet. So this is a network. Here we have networks, external and the one we created, and also subnets, external and the one that we created. Router comes handy, but we're not going to route here. And now we create the ports, which is actually a kind of abstraction. It's unbound yet. It's going to be bound when we create a VM. So it's going to be binding details will be filled after Nova successfully creates a Nova instance. Okay, so here is a command for creating a. Yeah, now you don't see anything. Okay, so now we try to spin up a VM. There's first. And VM on a second node. As you can see, availability zone defines the node on which the VM should be created. And this is Horizon, OpenStack interface for managing entities that were created. So we're going to log in there and look for VMs we created. Okay. So they are booted. Right, they have there's if config. So there was an IP address, which means that DHCP could assign IP address through the bridge domain. And there's another one. There's also going to be an if config. And now some traffic. So now we're pinging QRouter, which means that VPP created a BVI interface in the bridge domain. Now we're pinging DHCP, which should work. And now the other VM. Okay. Okay, thank you very much for your attention. That would be everything from my side. There's pretty much time for questions, if any are. So, if not, thanks again.